In this video, we will solve a problem which has dependent source. Okay. So again, take down this problem and pause the video and solve it. After that, you can verify. Okay. Find VC, voltage across capacitor, for t greater than 0, and already initial voltage is given. VC of 0 minus is 2 volt. It is already given, so you no need to calculate VC of 0 minus, it's already given. And you have one resistor 20 ohm, current passing through is I1, and 10 ohm resistor, and current controlled current source. It is current controlled current source. Which current is controlling? I1 is current controlling. So 1.5 I1. So magnitude of this current source is 1.5 I1. It's a current controlled current source. And we have capacitor 1 microfarad, and voltage across that is VC. So that only you have to calculate. So for this t less than 0 and t greater than not required, because already they have given VC of 0 minus already given. But only thing here, the difference is R equivalent. So previously it was easy, we just calculated the equivalent resistance across the capacitor or inductor. But here we have a 20 ohm and 10 ohm resistor, and we have a current controlled current source. Current controlled current source. So in the presence of that, what is the equivalent resistance seen by the capacitor? So for that, what you have to do is you have to find equivalent resistance R equivalent like this. This is similar to how you find in analog electronic circuit. In that given transistor or any amplifier, you are asked to find what is the input resistance, what is input equivalent resistance, output equivalent resistance. How you will calculate there? You will simply add a voltage or test source, test voltage source or current source, and find the ratio Vx by Ix. What you get, that is nothing but a equivalent resistance. So same principle we are going to use here. Remove this capacitor, apply a test source. It can be current or voltage, and apply KCL or KVL. Calculate the ratio Vx by Ix. That is nothing but the R equivalent. Okay. So in this case, I am applying a current source, and voltage across that current source is Vx. So I am applying a test source Ix, voltage across that will be Vx, and Ix is this one, and arrow towards arrow it should be positive, so I have positive sign towards the arrow. That is correct. So now you have to apply KVL or KCL for this and find Vx by Ix ratio. So R equivalent, if you apply the KCL at this node, what are the currents entering? 1.5 I1 Ix current entering, and leaving current, I can tell the current through this 10 ohm and 20 ohm. What is that current passing through 20 ohm? I1. Same current passes through 10 ohm also. So what is the how to calculate the current flowing through this one? You should know voltage across those two resistors. That is nothing but voltage across this and this. That we have already given, that is Vx. So voltage across these two resistors is Vx. So current passing through this will be Vx by 30. So I have written a KCL here. 2 incoming current Ix plus 1.5 I1 equal to outgoing current. Outgoing current will be Vx by 30. Okay. And what is I1? This is controlling source is I1. So I1 is Vx by 30. So if you substitute that one in the above equation, it is Ix equal to 1.51, you take to the right hand side, it will become minus 1.5 Vx by 30 plus Vx by 30. So if you simplify and calculate R equivalent, this will be R equivalent is equal to Vx by Ix. In that minus 30 by 0.5, that will be minus 60 ohm. See here, we are getting a resistance, equivalent resistance of negative value. This is possible because we are using a dependent source. So when we are using dependent source, there is a chance of equivalent resistance, getting a equivalent resistance with minus value, with negative value. Okay. So that's why we are getting a minus. So what is the tau now? R equivalent into C. R equivalent is just now we calculated minus 60 into 1 micro. So total time will time constant will be minus 60 microsecond. Okay. So because of this minus sign, see if final result what we are getting. So step 2 will be directly we can use that formula, that is Vc of t equal to a into e power s1t, where a is Vc of 0 plus. Vc of 0 plus is nothing but Vc of 0 minus, that we already know, that is 2 volt, it's given, into e power minus t by tau. So here minus t by tau we will get plus t by tau. So plus t by 60 micro we will get. So instead of exponentially decaying response, we are getting exponentially increasing response. So this circuit will not be stable, but for this analysis we can, for this problem purpose we can take this one. Practically if we are implementing this circuit, it is not going to be stable because output is exponentially increasing. Okay. So this is the result, 2 into e power plus t by 60 micro.